Hi pre-calculus students, this is our third video to review, focusing on the third standard from your packet, NCN A.3. And this we're going to talk about what the conjugate is and how it can help us when we're dividing complex numbers. Alright, so here we're given two numbers, Z1 and Z2. It says, find the conjugate of Z1 and how is it related geometrically to Z1. Great. So from our formula sheet, if we have a rectangular form of a number, z equals a plus bi, it says on our formula sheet that the conjugate of that number, we have that little bar to tell conjugate. I'll highlight that in blue right now. This little blue bar above our z tells us the conjugate of z. It will be a minus bi. But what that means in general, I'm going to put it in words. It just means make the imaginary part opposite. So looking for our number, the conjugate of z1, little hat, is the real part stays the same. A stays as a, so negative 2 is our real part, so negative 2 will still be our real part. The only thing that changes is the sign of the imaginary part. We originally had a negative 5i, and we're going to change that to a positive 5i. So that would be our conjugate. It says, how is it related geometrically to z1? So either we remember this for class, or we could quickly draw a picture and see if we can come up with what it is. So I made a little sketch of an axis over here. Here's my real. Here's my imaginary. And we have a number, negative 2 minus 5i, negative 1, 2 minus 5. I'm just going to sketch it so it's down here. That's our z1. And I'm going to put its vector there too. Now if I plot its conjugate, I'm going to do it in a different color in blue. Negative 2 plus 5i, negative 2 plus 5i, be right up here, negative 2, 5 imaginary, yep, right up there. All right, then make its vector, that's the conjugate of z1. So from this, I guess if I didn't know what the effect was, I would have to try and guess if it's a rotation or a reflection, because it could be either. If we tested some other points, basically it makes sense though that if we're just changing the imaginary and real, just the imaginary part, sort of flip-flopping the imaginary part from one side of the axis to the other. So our geometric effect of the conjugate is always going to be a reflection over, and we have to be specific here because we could have reflected it a different way. In green, I'm going to highlight what it would look like if we reflected it over the imaginary axis. That would be over here. That would be, that's our negative conjugate. So we have to be specific on which one we want to go. So it's a reflection over the real axis. Great. And this diagram also shows us, if it asked us, like, what's a number that's a reflection over the imaginary axis, it would be here. It's the negative conjugate to reflect over the imaginary axis. Awesome. Okay, part 2, it says find a complex number w written in the form w equals a plus bi, such that w times z1 equals z2. So this is actually a question off the first quiz we took, kind of our diagnostic quiz. It wants to know what w is, and we only know an equation relating w and z1 and z2. But we do know what z1 and z2 are. So I'm going to solve this equation for w, because that's what we're trying to find. So if w times z1 equals z2, I could think of this as, I want to get w by itself, and it's right now it's being multiplied, so I'm going to divide out a z1. Divide out a z1. So that gives me w equals z1 and z1 divided to 1, z2 divided by z1. So basically, to find out what w is, we're going to have to divide two complex numbers. All right, so I'm going to fill them in, our blanks here. z2 is 3 plus 2i, and z1 is negative 2 minus 5i. So it wants w in a plus bi form. The problem is here we have i's on the bottom. We don't like having an imaginary part on the denominator of our number. We need all our imaginary parts up top, so that we can just write it as one real part plus one imaginary part. And we found in class that the way we can turn a complex number into a real number is by multiplying it by its conjugate. So negative 2 plus 5i. Plus 5i. Oops. We're just going to do it on bottom to start. If we multiply it on bottom, we know it's going to give us a real number on bottom, which is good because that gets rid of the problem that we had with having this I in the denominator. But if we're going to do something to a fraction, we have to do the same thing to top and bottom to not change our quantity. So negative 2 plus 5i, we have to multiply the same thing on top and bottom to not change our quantity. Okay, so this is basically the important setup. We had to understand that we had to divide our complex number to figure out what w is, and then to divide complex numbers, we multiply by the conjugate of the bottom. So looking at the bottom, the conjugate of the bottom on both top and bottom of our fraction. All right, and then distributing this, I trust that we can do this at this point, but here it is in case we forgot. 3 times negative 2, so negative, don't want to write with highlighter. Negative 6, 3 times that is positive 15i, minus 4i, and then plus 10i squared. That's all over plus 4 minus 10 plus 10 i's and a minus 25i squared. We combine my like terms, negative 6 plus 11i plus 10i squared all over 4, positive negative 10 actually add to 0, so just minus 25i squared. And at this stage, we know we shouldn't have any I squareds in our final answers, so we can substitute I squared equal to negative 1 in all cases. That really just changes the sign. So it's going to be negative 6 plus 11i, and then instead of a plus 10, it's going to be plus 10 times negative 1, or negative 10. On the bottom, it's going to be 4, and then negative 25 times negative 1, that's going to be positive 25. And that's just going to give us negative 16 plus 11i all over 29. And then maybe as a fraction, we could, or as a decimal, we could approximate this as well if we wanted to graph it, or as a fraction. At this, actually, it'd be fine to just write it as a fraction, so let's do that. I would say at this point, w equals negative 16 over 29. We've got to split up. Both are being divided. That's our a term. That's our real part, negative 16 29ths. And then our imaginary part is plus 11 over 29 i's. If you want to do a decimal to graph or something, I'm just putting in my calculator in these fractions. 16 divided by 29, negative 16, so it's going to be negative 0.55, 0.552 plus 11 over 29, 0.379, 0.379i. Cool. Another handy thing is you need to be able to do this like we just did it with multiplying by the conjugate on top and bottom on the test. If you want to check yourself, calculators can do this kind of division for us. So right now I have my TI-84 in front of me. I'm putting in 3 plus 2i, and then in parentheses dividing by negative 2 plus 5i. Actually, no, negative 2 minus 5i. That was our original problem. And in my calculator, sure enough, I get negative 0.552 and 0.379. Awesome. So it's a great way to check yourself to make sure there were no errors. If there were any errors, you could go back and see if maybe you changed a sign or something when we were simplifying. Great. That's pretty much it. We need to know how to know what the conjugate is, what it means geometrically, and how we can use it to help us divide. that's essentially what's in this standard. Down here there are just 3 practice problems for you to try that out, and then I will have the solutions in class for you to check your answers before we take the quiz. Alright, see you in the last video.